Welcome to the second video in the series on the Rhino Grasshopper Python component. Real quick today, I wanted to just go over something that I covered in the first lesson, but clumsily so. So this shorthand reference going to RS for Rhino script syntax, that's typically because you have a really long library name. So when I said import math as cat, we can do cat dot and get all of the math functions because we're referencing as cat. But you'll notice math and cat are basically the same size, and cat has nothing to do with math, so that is flat out silly, and I just wanted to let you know that before we keep going forward, so you just don't start naming all sorts of functionality by names that make no sense. So what I want to do first today is build something using the native Grasshopper components, and then come back and construct something very similar in a pure Python component. So I'm going to start by drawing a couple of curves in Rhino. I'll go ahead and reference those. And go ahead and get some curve analysis going here. And make a loft. So now we have our endpoints and our lofted surface that we can use to get our area and do some analysis on it that will benefit our interests. So go ahead and get a little panel so we can read it. And you'll see that we get the area. It's a nice and dirty floating point, so I'm going to turn that into an integer. I can use an integer primitive or do an integer division. And both of these should give us an integer of the area solution of the area. 48, 14, 48, there we go. And we could use either one of these, just wanted to show an example. And so now if we edit our curves in Rhino, you get an updated area. All right, so let's do a little bit more with this. I want to define a ceiling of what we want our area to be, and if our loft is more than that, then it won't render. And so sort of a switch based on a ceiling. So I'm going to go ahead and get a little scrubber and set some values. Say with a floor of 1,000. All right. And I'm going to check and see if it's larger. It's going to be number to test, larger than. So is this area larger than our ceiling? And right now it is, and now it's not. And so if it's larger, we're going to hide it. So let me get the dispatch. What is that? All right, here we go. And let's reference our initial loft. And let that output surface. Go ahead and hide everything else. And now we have our surface. And if it is bigger, we got to change that real quick. And so now it's within our ceiling. If the geometry is too big, it hides. And so if we change on the fly and you make it larger, and it's going to disappear. And there we go. And so that's a nice parametric way to inform us on if a design is within the limits that are set by whatever predetermined factor. In this point, it's the ceiling of our area, and does the shape fit within that? And so that's a parametric tool. We can change that on the fly. We can change our geometry within the environment itself, and we can test that to a true or false and get the actual area that we have. So let's see how we do that in Python. And I'm going to end up putting this definition up for download. So I'll have all the Python and everything that's in this file will be able to be downloaded. So now up for the Python. So using the Grasshopper Python component, get started. I'll make some curves and get these curves out of the way. Go ahead and set those. And plug those into the X input. Go ahead and hide these. And I'm going to quickly go over, actually, let me get a pen. And notice it's a null output right now. It's because we haven't tested the component. And still getting null because we have no reference to a equals x. And now you'll see the output, single index. This is something to pay attention to because we have a single object is what it's saying. And the way to look at that is at the input. In the first video we talked about type hints and how to let the Python component know what type of information you're sending it. But another thing we have to look at is the access type. And there's an item access, list access, and tree access. And that's important by the way the component then reads the information coming in, not by the type, but by the individual list or list of list reference. And so we'll go ahead and see that real quick. So we have x is a set of curves, and so if I iterate them for I and x, that's an iteration over that, and we'll say a equals x. I'm going to comment this out. You can comment out using control / and both back and forth. So I've commented that out, and so that's not going to run when it's commented. And we're going to do for I and x, test that, and we get the error. And you'll see the error at the bottom is that iteration over a non-sequence GUID error. And so, yeah, it's trying to look at this as a single, it's seeing this as a single object because the access is as an item. And so it cannot iterate over a single item. And so if we change this to list access, immediately it works. And you'll see that each curve has its own index as well. And so that's a really important thing to know going forward. And so that's what allows the component to know what it's anticipating so the code inside can actually do the work it needs to do. Otherwise, it'll throw errors, but they're usually pretty obvious. But if you're sending in a list, make sure it's list access. Okay, so we're going to go ahead and make this variable, or I'm going to go ahead and make this variable curves, because that is what we are bringing in. And so when I am iterating, this is usually an index iteration if you're using I, meaning starting at 0 and then counting up for the length or the amount of items in a list. But what I want to do is go through the actual items in a list. So it's for, I'm going to use curve in curves. And there's sort of a, not that you have to, but sort of a standard I do is for plural for the list, singular for the item in the list. So then when we're doing work inside of our function or iteration, then it's logical. And so let's do go find the points on our curve. And we'll see curve start point and reference that curve. And so it's going to loop around each one. And so we can get a, do the same thing on the end. And we're referencing the curve of the curves we're iterating as the current curve. And I'll comment this out. And so, just to make that sense real quick, we're passing curves that we set initially. They're coming in as curves. We're making sure that right-click, they are coming in as a list. Since they are a list, we can actually iterate them. We're using a plural name to make it a little more obvious to us, or if anyone else comes and reads the code. You could just as easily say for bubbles and curves, I mean, you could use anything, but using the singular of the plural is a good way to do it. So from there, I'm going to go ahead and say a list of points. And what we're going to do is call this a list by using these braces. And this is an empty list. And so now I can pass these to that list. And what I'm going to do is say points.append start point, endpoint. And then we can say uncomment this, or actually I'll just leave that, comment it out, and just say A equals points. And so what it's trying to do is append, but it has to do it as a single item. And so if you go and we look at just the start points, you'll see that works. And we've got the points on either side. And now if we're iterating this and we're putting it into these points, what happens, as we already saw, is that if you try to pass two things to an append, you can't. Another way we could have done it, though, is pass it as a single object. So put parentheses around that. And that's actually what's going to be called a tuple. And now it's trying to look for it as a point because it's trying to interpret that. And so, again, just trying to show what looping can start doing. As far as a list goes, we're iterating this. Now, another way to look at this would be to look at a list object directly through the index. And so if we're trying to find the start point and the end point, what we could do is just create a reference as a line A is curves, and it is the 0 index point. And line B, curves. And we could say it's either 1, which would be the second one, or you can go a -1, and that means it's the last one, which in this case, since we only have 2, is the same thing. And so now we could get line A start and get that as, and for some of these, a lot of these, you can just type and the hint will start filling in as you're typing. And so if you want to just go through there, you can look at a lot of them with just what they are and just study it. In this case, start point, and we're going to pass line A to it. And again, we'll go endpoint. I already know that that is a function. And do a line B. And line B. And so now, these are just referenced variables for these points. There's nowhere for them to exist currently. So we could go down and create an A and a B, and in our output, create our own list. So a list is anything between braces. And so separated by a comma. So for instance, we could do line A, start, comma, line B. Or let's do line A, end. And we'll do the same thing with B. All right. And line B end is not defined. And it's not. We have this error right here. Now we see we have our points. Just like this. And we can change our curve. The points follow us. They're associated with the curves. And but that's a lot of verbosity for that. Pretty verbose code. Currently, our solution does not scale well. It's very fragile. If we needed to add another line, we would just have to be incredibly redundant. So what we're going to do is, or what I'm going to do is wrap this up in a function. And so in Python, the way we do that is first I'm going to go to comment this out, control /, use the def keyword for definition. And then you just name it whatever you want. I'm going to name this one make points. I can name it my points, whatever. And so then I have parentheses at the end and a colon. And everything within this that's indented will be part of that function. And so within the parentheses, we can pass variables. Variables just like what we did here within the component, we can create our own variables that get passed within our function. And so we're going to pass some curves, but I don't want to use this keyword or this variable that we've already set up as the input, because that would start polluting the space and be confusing. So I want to create a plural that is something that I'm going to internalize. So there'll be a local scope, meaning that it's only going to be within this function. So, and basically the curves is already global. It's already part of the outside of this function at the root level. So first I'm going to create an empty list. And a list, again, is brackets separated with items separated by a comma. And right now we're going to make an empty one, so we have nothing separated by a comma. We just have 2 brackets, and that makes you an empty list. We're going to end up using that to put our points in. And so I'm going to iterate the curves that would get passed in. We're going to use the singular and the plural. And that's just what I use because it's logical to me and I can read it and it makes sense. It's a pretty standard nomenclature for Python iteration. And so now I'm going to get my points for that curve, and I'm going to use just the keyword PTS for referencing shorthand for points. And I'm going to go to use the RhinoScript syntax library, and I just have to use the RS. And I have a curve edit points. Yep, there's a curve edit points function, and that'll just give me all the edit points of a curve. And since I know this is just a line, that there's just going to be a start and an end. So I'm going to pass it that curve, and now I'm going to iterate those points. So I'm going to use PT as a shorthand, but let's see, colon. And so this loop will happen within this loop that happens within this function, and they all have the indentation of this, all of the information that happens within them. So, and now here I'm going to take my points, or my underscore PTS, and append it, add to that list, that point. And so now this is my function. If I pass it a list of curves, that it will go through each curve, and for that curve it will find the edit points, and then it will go through those points and it will append it to my points. And now if I call this, I'm going to get an error, and it's right now it's because of my output variables. They're referencing things that have been commented out, so they don't exist. So I'm going to go ahead and comment those out. Again, control / and I'm going to just do my own output for A real quick, just to test this. And so now we're going to make our makePoints function, and we're going to pass it the curves, the curves, the variable being passed into the component. And now you'll notice the solution gives us null, and we know that's not true because we should have points because we are passing curves. And the thing is, within a function, it's been called, but it has to return something. So this loop, the outer root of the function, has to, where we've set our empty list, we now need to return our list at that level. So now I'm indented at the same level. We've gotten out of each list, and now I'm returning my underscore PTS. And I don't have to put the brackets here. I'm just returning it as an object. And now we have our points. And so now our points will follow our lines, and we are good to go. But right now, the native components still have a lot of elegance on us. We've just got this done. Now, the first thing I'm going to do is just get rid of this code we are no longer using. We've got basically ourselves a single function. So we got the equivalent of the endpoints, and we've got it a little more elegantly. And the interesting thing too about this was we could reuse it with any group of points. So this is completely reusable indefinitely. Next step we got to do though is get the loft, the area, and feed that area as an integer. So this is where the Python component really gets pretty convenient. So we're just going to say, make a little variable my underscore srf or my surface, and oh, excuse me, I didn't reference the RS for the RhinoScript syntax. So add a loft surfaces. Then it's going to add ask for all the curves involved. We can see that object IDs, and then it has all these other variables it can ask for, but we're not going to pass that at this point. And we added a capital. It's a lowercase. it cares. So Python is helpful, but it's not that helpful. Which is good. So now A is referencing the make points, and nothing's referencing the mysurf, but we can go ahead and allow that for B. We have this little B space for an output. And test it, and there we go. We've got our surface built with the Python component only. And now we still got one component. This is starting to get a little more stringy. And so we can even go ahead and give a few more outputs and get ready for our next steps. Okay, so let's go get the area of this surface. And I'm going to go with the same type of naming convention, just so again it makes sense. So now it's my underscore srf underscore area. And so go to the rs, go use that Rhino script library. Now there's a whole area on surfaces, and one of the functions right there, surface area. All we have to do is pass it a surface, which is the my sr underscore srf. And now let's go with C. And let's wire that up. And there we go. And we can get that first object as well. And now you see that we have that integer problem too. And so here you had to use these other components. Well, we have our nice little tools that we can use using Python. And so I can do it here, I can do it here. It just depends on where I want to define that integer and if I need it as a floating point at all. So I don't think so. I'm going to wrap just the initial area call. So I just go int and put it in parentheses. And so that integer call within the parentheses is the surface area. Test that, and now we have a nice integer. And notice our component it's nice and slim. Suddenly the elegance is on the Python side. Now we just need to go do our own dispatch and find out if the surface fits within our floor and ceiling. So now I'm going to add some inputs. We can even go ahead and add this scrubber just to make it easy. And we're going to already use the Y. And we'll go ahead and add one more. And so we're going to go ahead and make this an integer coming in. It's a type hint. And go ahead and make the scrubber an integer, which I guess it should be up there too. Why not? And let's go ahead and name this floor, ceiling. And we're talking about these numerically. Actually, yeah. And we're just going to make the floor as low as it can go. And we'll make the ceiling as high for now. Now we can go back and check our surface and the area. So, and for that, we could do a function, or we can just do some quick iteration, which I'm just going to do some quick iteration now. And basically, we're going to say Actually, we're just going to do some comparison, excuse me. So if my surf area is less than the ceiling, let's see, my surf equals none. It's a keyword none, and then we'll have D equal my surf. And right now it is bigger, and so now it is the right size. And so there you go, we have it functioning. And so we can even go nice and just go our points. What do we have here? Surface, area, oh, and we have our surface twice. We'll just go ahead and get rid of D for now. We do not need it. And we actually don't need out either. And so there you go. Test, and everything is working. So we have our floor or ceiling. We could be using the floor elsewhere. Right now we're just referencing the ceiling in a comparison. And so just to get back to relating to what's happening in the Grasshopper native components. So we have our curves referenced. This is where we're getting our endpoints within the Python code. For each curve, we're grabbing those edit points and then adding them to a list. These you have them natively, but then we're able to get our surface and area just with 2 lines of code. Whereas this took 1 component, 2 component, get it out, then turn it into an integer, and actually read the integer. And so we gained a lot in the code for just 2 lines of code. And then we're just doing a simple comparison. And again, here you need 2 components, and here you just need a couple of lines of code. And everything that we're responding to as we look back on it is input variables of curves, floor, ceiling, output variables are points, surface, area. And now you'll notice right now we're getting the nulls because we still have A, B, and C. So we just have to go points, and area. And there we go. And we can even do exactly what we did on the native solution. And so now, there we go. Thanks for watching. I'll have this code and file up for you to download, as well as a reference to the Think Python website. And thanks again. Look to have a new video soon. Bye.